Let's start with some definitions. So a quantum is the minimum amount of energy that can be gained or lost by an atom at any time. A photon is the massless particle that carries that amount of energy. So the quantum is the amount of energy and the photon is what carries that energy. This is Max Planck. Max studied the light that was emitted by heated objects and quantized that energy, basically put a number to it. He discovered that matter absorbs energy in whole number amounts, and he called that amount, that whole number ratio, he called that Planck's constant. This is Niels Bohr. Bohr developed the quantum model for the hydrogen atom and proposed that hydrogen atoms only had two states. The ground state, which is the lowest allowable energy level for an atom, or the first energy level, and the excited state, where it gains energy. He also stated that electrons could only move in certain paths around the nucleus, so in those circles. This was later proven to be incorrect. However, we still use his model in those proven paths when we draw things in 2 dimensions. Let's look at the difference between ground and excited state atoms. We have our atom here, and this is the first, the second, and the third energy level. Let's say we put an electron on each one of those energy levels. The electron on the first energy level closest to the nucleus is going to have the lowest energy, and the one furthest from the nucleus is going to have the highest energy. If we take an electron on the first energy level and add energy to it, that is going to become excited and it's going to jump to another higher energy level. It becomes unstable and it immediately releases that energy so it can drop back down to its original ground state. The energy released has the same energy difference between the first level and the third level. If we put an electron on the second energy level and add energy to it, and it jumps to the fourth energy level, again, it's going to become unstable. It has to release that energy so it can come back down to the second energy level for its ground state. Again, the energy released is the same as the energy difference between levels 2 and level 4. So energy absorbed and later released has a certain wavelength. If that wavelength is within the visible spectrum, we see it as color. It's because of this that fireworks are so fun to watch. Energies released here and here are not visible to us. They're either too large or they're too small. But the energy that is released right within the visible light spectrum is what is visible to the human eye, and we see it as color.
Created using Photons.